Hey, let's discuss unit conversion. So there are many different names for different size of measurements. Okay, we're not going to talk about all of them. As you get older, you'll see that depending on what you're studying, right, we'll need more and more different names to express how big something is or how small something is. Okay, so let's start with the basics. Let's take a look at this line. Okay, so the center here, okay, is meters. M stands for meters. So hopefully you've seen a meter stick. Okay, meter stick is roughly half of my height, right? Probably from where my hip to the top of my head is about a meter. Okay, so some language around meter. So now you know how big meter is. Okay, the more familiar one is, you might have seen probably this one first, centimeters. So maybe you have used a 30 centimeter ruler. You've seen a centimeter there. So centi means actually 100 times smaller. Okay, so for you to, because it's 100 times smaller, for a meter, right, in a meter, there's actually going to be 100 centimeters. Okay, does that make sense? Because 1 centimeter, so if meter is this long, let's say, and centimeters that long, and you actually need 100 of those to equal to a meter. So you write that this way: 1 centimeter is equal to a meter. These stands for deci. Okay, decimeters, and this means 10 times smaller. Okay, because it's 10 times smaller, so that's a centimeter. A decimeter is about there, a decimeter, okay? You'll need 10 of these to make a meter. So you say 10 decimeter is equal to 1 meter. And there's two m's here. This first m here represents milli, okay? Millimeter, and that is exactly 1,000 times smaller than a meter. Okay. So we ordered this way because to get to here, we actually need to times it by 10. Okay, to get to here, another times by 10. To get to here, another times by 10. So to get from meter to a centimeter is times by 10, 10, which is 100, okay? 10, 10, 10 gives you, right, 1,000. Okay, and then of course going this way, we actually, because this is actually 10 times bigger than a meter, right? We actually have to times it by 0.1 or divide by 10. Okay, timesing it by 0.1 is the same thing, right? Timesing it by 0.1 is the same thing as dividing by 10. Again, this is now 100 times bigger, so you only need 0.01 of this to have a meter. And then kilometers 1,000 times bigger, so you need to multiply by 0.001. You need 1 in 1,000. This represents 1 in 1,000 to have a meter, okay?